Welcome everyone. So it's a pleasure to be here with all of you, especially with Mash, Heather, and all the Maria as well, all the Codurance stuff. Well, there you go. This is the fourth session, isn't it?
Yeah.
I jumped the last one. I wasn't here, but yeah. So exciting! So exciting! I see that we have like many things to cover. We are also here with Helder, that is also from Codurance, but he also part of the Software Crafters Madrid. You want to say some more words, Helder?
Yeah, sure, of course. I need to invite everybody to be on our communities and share the links with your mother, your sons, your grandma, and start learning Clojure as always. So thank you all for being here. It's a pleasure to be in this forum. And for today, we have a very special session because we have homework for today. So this is the first time that we have homework, and we need to have installed all the development environments, execution, and so on. So we're expecting super fun session today. And thank you all, Maria, Matthews, Mash, of course. And it's all yours, Mash. How are you?
Good, very good, thank you. So the homework, from what I remember, was that you would have your REPL running, and you'd be able to execute from a file onto the REPL. If you hands up for people who have actually done it. Don't worry if you haven't. As usual, I will show you how to do it in the session anyway. Maybe Helder, I am thinking, oh, very good, Helder's done it. Well done, well done. I'm thinking homework is probably not a good idea for meetups because people, tend not to come if there is homework. So that's okay. Don't worry. Actually, today is all about trying to solve a kata. For people who don't know what a kata is, it's a small exercise that you can do over and over again. The idea is to solve a kata in Clojure, but using the REPL. So REPL, hello. So the REPL sits in between kind of test-driven development and developing blind, basically. And it became quite popular in languages like Ruby, dynamic languages, and it is very popular in Clojure as well. The REPL allows you to try things, throw away things very quickly, right? And it's a way of solving things, getting to know parts of the problem or the language or its features and all these kind of things, right? So I will, first of all, there's a few more people join. So how many of you actually put hands up if you don't have an environment at all? Hands up for people who don't have an environment. The reason I want to know is so that I can show you how to use the how to use a Clojure REPL. So you can use at the bottom. You will see like a way to kind of put your hands up or any reaction or just speak up if you don't have a REPL running. Yeah. So Mamadou, I hope I'm pronouncing your name right. Doesn't have a REPL running.
Hi, sorry. I'm in the office. That's why I cannot put the webcam. Sorry for that. But actually, I just into the website and created my account. Well, I had an account before with my GitHub, so I already have a REPL running Clojure.
Oh, you do have one running.
Yeah, I have a hello world actually. Yeah, so I don't know if that's enough.
Which one? Sorry.
I said I have a hello world application working.
Oh, perfect, perfect, yeah. Perfect. Okay, so you have it running. Anybody else who doesn't have it running? So hands up who doesn't have it running. The REPL, REPL is the Clojure REPL. You can use Lineagon and say line REPL. Anybody, feel free to put your hands up because then I will show you. But if no one puts their hand up, then I won't show you. Then I'll just move straight into some of the recap. And okay. So it seems like
Mash, yeah, just to confirm, I have like the lane installed that can run a file, and I also have the command line to run like
yeah, perfect. Perfect.
code.
So that's enough.
The basic, right? Okay.
Yeah.
Just
Homework was to actually maybe be able to run it from a file, and I will show you how my current system is set up. But if you don't have it, it doesn't matter, because actually what I am we are going to do everything in the REPL. That's why I'm keeping these exercises quite basic and small, because that way people will follow, and it's important that you follow me. So, otherwise you can just go to YouTube and maybe look at people programming in Clojure. The whole idea of this workshop is for you to actually try things, to become more confident with things. Yeah. Okay. So let's, I'm going to share my screen and then we can get started. Yeah. So share screen, and there it is. Okay, so you can see this instance. Yeah. Perfect. Right. So I'm going to remove everyone's I can't see faces anymore, because otherwise I don't have enough screen to actually look at my code. So that's why I will remove everybody. And can everybody see the code base? My browser, I'm my command line, which says Software Madrid. Yeah,
it's perfect. Yeah.
Perfect.
Yes.
So
the left
the way
have
to
the
run
best editor in the world.
Yes, Wim. So the way to run REPL is line REPL. There are many other ways, and I've showed that before. So you can always go back to the previous videos, and you can see how to run the REPL. How else to do it if you don't have. If you don't have REPL running, and you would like to, you can actually go to tryclojure.org, and you can actually follow along using the REPL that you will see there. Yeah, so that you can follow along there as well. Okay, the thing I am going to show you is an example exercise. Yeah, so the exercise that we're going to try today is called leap year. And I'm going to put that in the Zoom link as well in chat. Okay, so in the chat. So this is the leap year. Yeah, so you should be able to see. Okay, and also you should, so if you are not able to see it, let me know. Actually, what I'm going to do is share my desktop so that you can share my browser. Just one sec. Okay. So you should be able to see my Google Chrome here, and I'm going to show you the leap year example here. Yeah. So the way it works is, so leap year is a year that is divisible by 4. So every year that is divisible by 4 is possibly a leap year. So 2016, 2020, 2022. So you can go to this website and you can see the rules. Yeah. And then we are, but if it's a century, then it's normally not a leap year, even if it's divisible by 4, right? So 2021, 2022, 2100, 2200, etc. They are not leap years. But if it's divisible by 100, but also divisible by 400, then actually it's a, so 20,000 was a leap year, and 2400 was also a leap year. Yeah. So we are going to write a small program that will implement these rules. Yeah. Simple. Okay. So the best way to actually write a routine in Clojure is using the defn function. Yeah. Okay, so did someone put their hands up? No? All right. So defn is like a method declaration, as I showed you before. So we are going to create a defn.
Mash, just one thing. I don't know if you're writing the code or if you're just saying, because we still see Chrome.
Thank you for letting me know, because I'm still showing you the other one, right? Okay, so going back to, yeah.
There you go.
All right. So defn is the way to show to create a function in actually a macro, but it defines a function in Clojure. I've described that before as well. And you can say defn leap year. If something returns true or false, you by convention put a question mark. It doesn't matter if you don't, it's not typed or anything, it's just a convention. So we pass it a year. So this is the parameter declaration. And we return, we receive something back. So I'll say nil. Yeah. So this is described now defined a function. Now we can call this function leap year. We can provide whatever we like. In fact, it can just be anything really, like let's say any number or whatever. It doesn't matter because it's not typed, right? So it will say nil. In fact, and so we've got something running. If you have a REPL environment running, it's actually easier. That's why I wanted you to have an environment running, but I will show you in so in here. I have a Vim environment running, as you can see, and I will define here def, and so look right at the bottom. So just to show you here, yeah. So defn and leap year. Oh, sorry, this is actually not good. Let me open something a bit nicer up. Yeah. Okay. So this is a Clojure file. So I can define something a bit. So defn, yeah. Leap year. Same thing. Takes a year. Returns nil. I can evaluate this. So every time I define it, it's the same as going in the REPL. So it's the same as in here. In the REPL, I go like this to define my function. I can in the same way define function in my file, right? And then I can evaluate it. And as you can see, it's evaluated and it's returning nil. Just to show you, let's say I return a true always, and I evaluate it again. And now if I call leap year here, so it returns true. Yeah. So what that do is not to have to kind of go on the command line, because command line is not an editor, but you can do REPL driven development from the command line, or you can do it from your file. It's either way, it's fine. Yeah. Okay. So I can, for example, in here now do leap year this, and I can now evaluate this. As you can see right at the bottom left, true, because it's sent that call to the REPL and gave me the result back. It's the same thing as what I did here, like this. Yeah. So this is basically what we're doing. We've created a function, and now we are going to test it, basically run it, see how it works, and test it. The only difference between REPL-driven development and test-driven development, like two big differences. One is that the verification is with your eye, right? You can't run all at once unless you're verified and you set the tests up properly or verification up, and you don't have them, so you can't keep running them. So you don't have the regression aspect of what you get with test-driven development. However, I will teach you test-driven development in Clojure in the next session. Yeah. So REPL-driven development is very good if you're trying out things. Oh, how this method would work, these kind of things. Yeah. Okay. So now let's go back to the rules, and we know that everything that is divisible by 4 is actually a leap year, right? So we can redo this. So I'll chop and change in places so that you feel comfortable either in the REPL or in the other side as well. Yeah. So we, in this case, leap year, we're saying divisible by 4. Okay. Could anyone, let's say that I wanted to now here write divisible by 4. Yeah. Could someone actually write me a piece of the chat to just that little small statement to say how you would divide something by 4 and return true or false if it's 4 or not? Give it a try. Put something on the chat for me. So what I'm gonna do is give you a few letters. Yeah. Okay. Yeah. Okay. So that's not Clojure, Maudu, but good try. That is so Clojure, every function is code 4. Okay, so let's try that. That will not work. Okay, equals 0. Much better from Banner. Bernard, is it? Yeah. So let's try that, Bernard. So we are in the REPL, right? So remember, you can do whatever you like in the REPL. So equal 0, which is good. Mod for n, yeah. N would be the number, so that whatever the year would be. So let's say the year we were providing was year 1996. I say that's a leap year, I know. Yeah. False. Why is that false? Let's try PIOTS divide. Let's see, x in there, x would be a number, 96 by 4. No, that doesn't return true or false either. I think the one that you gave me, I think if you swap the arguments, because one is the divider and one is the divisible. Okay.
Yeah, you have to.
Oh, there you go. That
switch.
gives you true. Yeah. Perfect. So I did it the wrong way around, but that's perfect. That's a very good try. Okay. The other thing is that Clojure has a function called 0, right? Yeah. So mod num_diff. Yeah. So yes, similar, right? So Clojure has a function called 0. Yeah. Yeah. And if you give it 1, it will be false. And if you give it 0, it will be true. Yeah. So there's a 0 function. So we can maybe make your function a bit better by just saying, is it 0? Because it's a bit more readable. Mod of year 4, is it 0? True. Perfect. Now we can try it again with something else, which is, let's say 97. That should give us false. Perfect. Okay, so we now have a bit of code that's telling us that, you know, how to do that in the REPL. Now, this is the key that is actually more powerful than writing a test from the outside. You can actually try out small bits of code. Yes, Bernard, exactly. So you can try out small bits of code, see how that works. Yeah, and then you can put it in the math in the function, and then you can create that function, and then you can call the function from outside like you would do with TDD, and that would so you kind of start things small, and you know, you're running things without having to Google things that will this work, you kind of You're not guessing, you're running things. So this is the power of the REPL. Yeah. So now I am going to, in fact, copy exactly what you have written there, Bernard. And so define, yeah. And we are going to do leap year that takes in a year. And, sorry. And then that would be 0 mod, yeah, year 4. Yeah. So this is our first, I'm going to evaluate that. Okay. And now when I do the last time that I did the which was leap year. So if I do leap year 1996, it's true. 97. Ooh, that's true as well. So why is that true? That's maybe because I haven't evaluated it. Let me just check. Okay. Yeah, false. And the other one? Cool. So that's working. That's pretty good. Okay. So what we are going to do now is look at the next bit of the code base, which rules, which said, well, if it's divisible by 100, then it's not a leap year except if it's 400. But we'll look at the next rule later. Yeah. So now what he's saying to us is that if it's divisible by 3200, by 100, so then it's not, right? So that's something that we want to do. So I will again write like 2200, yeah. But that's saying true, so it's wrong, right? So it's a kind of failing test. That should not be true. Okay, so who's gonna try like taking a little thing that will actually, if it's divisible by 4, but not divisible by 100. So on chat, someone could give me a hand. So 0 remainder 100. Okay, so that would, let's see 0 rem, let's say 19, this case it was 2200 and about 100. True. Okay, so that's right. Now, okay, cool. That's very good. So you can provide an and, yeah. So in here we will add. So what we're doing is we're saying, okay, remember Clojure executes from in to out. So we know that we have two rules. We have that first rule that I created, yeah. And then the other rule that you created was 0 remainder 100. Yeah. Now you've actually done a very functional style thing. You've combined the statements in and, right? I purposefully said the rules like if it's that, then this, yeah, because people, when they're thinking imperative, they start thinking if statements, yeah. But actually, you've done a very good functional thing because you are expressing rules, yeah. So we're saying that exactly. So that's good. So we're saying that these two need to come into this AND statement, yeah? Sorry, when I run Zoom, I get some problems with my keystroke, don't always go through. So we know that these two statements have to go into our AND statement. So I'm just gonna put them in the AND statement. Yeah, just tidy it up a little. Okay, so we're saying, so this has to be true, that it is divisible by 0. And this has to be true, that it is not divisible by 100. Yeah, okay. So now if I put this in and go back to my leap year, cool. Well, this is still returning true, right? Because that should be false, isn't it? Maybe it's just, okay, let's see. Maybe I'm missing something here. Sorry, just a second. Leap year and 0. Yeah, that was returning true. So 22,000. That was wrong. Sorry, my bad. This 0 rem 200 is wrong, because that should return false, not true. Yeah, because what we're saying is that it has to be not divisible by 100. Okay, so but this thing is giving me a true, but what actually I need is a false from that statement. Yeah, so how do I get a false? In this case, I could, even mod would work the same way. Would mod return the true as well? Yeah, yeah, so true. So what I need is actually to make it a not. Yeah, so not would return a false. So I'm going to not use the remainder, which actually is same as mod. So I'm going to use the mod in this case, and I'm going to this, because that's the thing. It has to be not divisible by 100 to give me the right answer. Yeah. Okay. So now if I go back to leap year, false. Yeah. Whereas leap year 1996 should be true. Cool. So that's working quite well, isn't it? Now, what I can then do is we can start thinking about, actually, it is getting a bit complicated now, because we have these two different cases. Yeah. And you can make us, like, you can start changing things, but if you just checking the next thing, like TDD gives you regression, but the REPL is not regression. So how do we solve that problem? So in TDD, you can run all the tests, but in here we can't run all the tests. So can we? So how would you solve that problem, where actually I'm not just looking at the next rule that I need to verify, but I am looking at the previous rules as well, that I'm not made any mistakes making the next rule correct. How do I do that? Help me out here.
Just one quick question on top of your question, Mash.
Yeah, on top of that question, okay. You're giving me answers by more questions. Go on.
No. But this is like, you mean without any other tool? I mean, because usually we would like say like I don't know, some library to run a test, but we can even just assert, just write the function and assert the value. I don't know if you're going in this direction.
Yeah,
just
exactly. We
write
are
the
just
function
working in
and
the REPL, right? So maybe there is a function. No, yeah, replay history is a good thought, but no. But why don't we use a function that tests what the leap years are? So you can write a function, because remember, REPL is not automatic. You're just looking for the results that with your eye. Yeah, you can verify your eye. The assert statement is your eye or your eyes, right? Is equal. Yeah, you can, but the thing is equal will, or we can do is equal for sure. So you could say, for example, like def test, but now we are cheating.
I mean, yes,
we're using tests, right?
All right.
Because then you have to run tests in a different way, because def test will just define the test, but how do you run it? And then you have to invoke the test macro to run those tests. So you don't use the testing API. Yeah, you can do something like this. Think a bit functional. Okay. In testing, often these things are specification, maybe parameterized tests, so that kind of stuff.
I'm a little bit lost. I don't know if you can rephrase a little bit the problem that you're asking.
Okay. Yeah, let me rephrase. So the question is that, my code is getting a bit big, right? And I have just implemented 2 rules, and I'm just about to implement the 3rd rule. Yeah. But I want to make sure that when I implement the 3rd rule, that the previous 2 rules are working as well. So one option is that I can use the kind of examples that I had in the previous test to call each one, like I can call, like I did. So I can call this and say, yeah, that wasn't that case where it's not divisible. And that case that should return false. But now that I'm adding another one, do I have to keep running all the verifications every time? Or can I do something that will actually make this easier for me?
Okay,
So
I'm not fully sure if the answer is right, but I'm starting to smell here something like partial functions, something like that. Maybe just apply one for the 4th, the other one for the 100th. Don't know if
no,
kind of.
no.
Okay,
no,
okay.
but we may come to partial function later. But this is not the reason. Okay, this is a function. Functional languages are a good way, and this is the power of functional language. In functional languages, you apply functions to data. So this is a good clue. So you apply functions to data. Your input is data. And your output is data that actually is, again, very similar. Mamadou has his hands up.
Yeah, sorry. Well, I'm not sure if I'm correct either, but are you referring to write a simple test? For example, since we have a function, it's a input and output, so we could write a function to test all of the test cases that we did in the console. This way, when we implement, when we add more features, we just run the test and make sure all the tests are passing, and then worry on the new implementation.
So very close, very close. Yeah. So basically, the thing that is that you don't write any dev tests, because that was one given to me, because then we go into test-driven development, and they are more cumbersome for REPL-driven development, right? So what I'm teaching you is REPL-driven development. Yeah. So the one key in here is what I meant was that, data, right? So let me show you is that we can create, so I'm on the left here. We can actually create some data. So we can say, well, you know what is a leap year? Yeah, we know that 1996 is a leap year. Yeah, oops, sorry, my strokes keep getting missed. Okay, and yes, exactly. So 1996 is a leap year. 2000 is a leap year because it's divisible by 400. Sorry, I'll come back to this later because we know that 2000 is a leap year. Implemented it. So I'm just looking at the rules and thinking, what are the leap years? Yeah. So 2000 is a leap year. 2004 is a leap year. 2016 is also a leap year. Yeah. 2020 is a leap year. 2024 and so is 2400. So now I know these things are leap years. Yeah. So you can do this in the REPL as well. So you can type this in the REPL. And now I can define this def. So leap years. I can call this leap years. This is like a variable, right? And then I can put all these things in my vector or list, whatever you may want to call it. Now I've defined what all the leap years are. Yeah. So I put those in there and I can say, well, what are the leap years? And it will give me all the leap years. Yeah. So how do I apply my function to those leap years? Now I have a list of all the leap years. I can apply my function, my leap year function, to all those leap years and see what the results are in a big long list. Go on. Map, exactly. So map, right? So let's see doc map first. It takes a function and a collection or multiple connections. In our case, we just need one collection. So map leap year is the function, and leap years is our true, false, true, true. So for 2000 and 24,000, it's false, but they should all be true. Yeah, which is good. So we have a regression test, right? So we can do the same thing and say, well, what about the not leap years? Yeah. About the not leap years. I have them here, like quite, of course, you can have your own. Yeah, these are not leap years, right? And I can evaluate that as well. You can evaluate them directly in your REPL, basically, as well. But it's the same thing as copying this line and sticking it there. Yeah. Now I can say not leap years, and I get that list. What if I apply my map function to not leap years? Oh, that part is working. So the only thing I've got left is that 400 thing, but I've got my regression test going. Yeah. So again, I'm just applying functions with test data, looking at it. Yeah, it looks right. This is REPL driven development. right? This is kind of a very fast, like try this little thing, put it in that function, try this, call it multiple times with my test data, this and that. You know, that's how REPL-driven development works. It's like prototyping. You're exploring the problem and the solution together. And that's why people swear by it. It's actually a very fun way of developing software. Yeah. Okay. So in our case, we've got the last bit that was in the except if in the rules, except if exactly divided by 400. So there are a couple of falses in the leap years, like this one and this one, they both are divided exactly by 400, which means they're leap years, but that's not what our code is doing. So anyone care to add that rule for me? Yeah, pretty much. Okay, so what Badar has showed us there is as simple as, right? So what we've said is that like there is an and between these two. So if it's 0, right? And divisible by 100. If it's divisible by 4 and divisible by 100, then it's, or if it's divisible by 400. Yeah. So what we can say is that there is another thing. So these two rules go together. They're ANDed. So if it's divisible by 4 but divisible by 100, it's or not divisible by 100, then it's a leap year. Or if it's divisible by 400. Yeah. So we can just say, well, okay, so in our case, there is another one. Sorry, so we are saying that 0, yeah, mod year, yeah, 400. Okay. And we know that this actually has to fit into an or, yeah. So it's this one or this one, yeah. So we add an or, yeah. And we say, well, okay, this one. Or this one. Okay. Sorry. So I can make this a bit. Okay. So now we know that this rule is saying either it's divisible by 400 or it's divisible by 0 and not divisible by 100, right? So if I evaluate that, yeah. Now let's look at the false, not leap years. They're still false. How about leap years? Still false. So maybe I haven't. So 0, 400. And let's try again. Yeah, it's all true. Sorry. It's just that when I run Zoom, for something is wrong with my keystrokes. But yeah, so all the leap years are now true. And all the non-leap years are false. Yeah. Yeah. So that's pretty cool, eh? Right. And we've got some examples of using partial. Oh, so you're defining a function divisible by So you can create so now you can start refactoring this. Yeah. So some people are saying, well, okay, you define the function divisible by, and then you say divisible by year 100. There is actually an even better, which is to create a closure. Yeah. So I showed you the closure, how closures work and that kind of thing. Yeah. And let me just show you that again. Just moving the screen a bit. Right. So what you can do is you can create like a closure for the test. Yeah. So you can say like a partial divisible by. Yeah. Okay. So what you can say is you can use the let. Yeah. So you can say let divisible by. Yeah. Okay. And now you're creating a partial. Yeah. Partial that takes a function, which is our function. So I'm creating another function here and saying 0, just like I did before. Yeah. Mod year. Yeah. And then we pass in the next parameter, which is the parameter for the partial. Yeah. So I threw partials before as well. Yeah. So in fact, what you can do is try this in the REPL. Okay. So let's try this in the REPL. All right. So we're going to do something. So we define a partial, right? So let's say def, right? Div. So I'm not using defn. Remember, defn creates is a macro for creating a function in a particular way, but actually the thing that I call will return a function. So partial returns a function. So you just use def. So you say div by, yeah. Okay. And then it's doing a partial, anonymous function. This is same as saying fn, yeah, 0. And then mod year %. Yeah. Okay. Oh, sorry. This is the problem here, because in this case, let's say the year is 96. Yeah. So it's a closure in this case. In the other case, I'll show you, right? Because year doesn't exist in our context. Okay. So now I can say div by is true. It's taking in the 1996. Yeah. So now I can say divisible by 4, divisible by this, blah, right? So because it has the context of the year. In this case, I have hard-coded it. In this case, I am actually defining it using the, so it's not a closure, but I'm defining it using the year provided. So now I can actually make this much simpler by saying, so rather than saying 0 and this, I can say div by, yeah, divisible by 400 or div by 4 or not div by 100. Yeah. See, already making it much more simpler. Because I'm using an inline partial definition, I have the context already. I don't have to worry about an extra, which actually just makes it a bit, because so then you can read it. Is it divisible by 400 or divisible by 4 and 100 and not 100? Yeah, so if I do this a few times just to make sure they run. So now I can run the with leap years is still true and not leap years. Sorry. Okay. So is it divisible by 400? No. So not leap years should be false, right? Okay, let's see what's gone wrong here. Okay, so partial divisible by is fine, or 400 or 100. So I can actually take this and put this in the brackets. Cause anyone can see any problems there that I can't see? No? The first thing I'm gonna do is the div by partial. Yeah. So div by 4. The other way I was defining is, let's take a not leap year, 1995. Yeah. So now, is it div by 4? False. Yeah. So that part is working. So this div by is working. How about div by 400? So that all works. So then we got or div by this and this, right? So if both of them are false, then it will return a false. So in our case, the 1995, so leap year, (1995). Oh, it does return false. Okay, so what is my not leap year? Yeah, so then if I map leap year with not leap years, sorry. Oh yeah, I don't know what went wrong there, but it probably didn't update it. My keystrokes are a bit messed up. That works fine. So with not leap year, it works fine. And with leap years, well, actually, it should also work fine. Yeah, there's something wrong with my keystrokes. Because I can say leap year. Yeah. Then I say 1996. Oh, that returns false. Yeah. So that part, so 1996 is false, but it should be true. So if I just do this, so div by, yeah, and that was, let's redo this one. Yeah, so 1996. Yeah. True. See, it's because of the div by thing that I'm defining here. It's getting confused with this div by. So my bad. So I'm just gonna make this divisible because I'm trying it both in order to show you. I'm doing it both in the REPL and in here, and it's getting confused on which one to use, right? So divisible by and yeah, that should be fine.
You had a little typo in the 92.
92.
We miss
Oh yeah.
9. Yeah, okay.
Thank you. No. And it was a symbol by the line 92.
92.
Be visible. That's right, isn't it? Or am I missing something? Oh, my bad. So that was the problem. I'm missing the block. So it's using the other one because I was putting it in there just to show you. So moral of the story, if you're using your REPL, don't just use the REPL as well, because you can get yourself into knots, right? Okay, so this work now. Yeah. All right. So I'll just use different names. Yeah. So now if we map leap years, true, and map not leap years, false. Yeah. It was just because the let block has scope, but because I was calling by, even though, and I was defining it outside, it was still resolving to the one outside. But that's fine now. So when you do a let, the let block is scoped. So this would only be visible inside the let block. Yeah. It's like a local variable or constant. Yeah. So that also shows you how to kind of refactor, but still run. As you could see, I was because I have regression and I had a pretty nasty little bug that I'd introduced without even intending. But because I have the regression, I can actually run it. That is not working. Yeah. And so then I could go back and see where there was a problem. So even with the REPL, it's good to start thinking about how you're going to test it. And you create a few like harness functions that will allow you to test the functions applied to many different permutations of the data. Yeah. So that's pretty much it. Any questions? 2 minutes left.
So let's give you room to the people to ask questions. If not, I have one. Really...
You have one?
Yes. So just for me to understand your workflow, Mash, so you have when you write a file, you have something a plugin or something like that on your Vim that compiles the code.
It doesn't actually compile, because basically in a convenient way, what it does is it sends this form, like say wherever I am in, I have a shortcut that sends that piece of code. So the outermost form, right? So this form basically to 97, that's a form. So anything within different brackets is called a form or a S expression. Yeah. And it sends that through the REPL. It's exactly the same as copying and pasting it into the REPL command line. So that's what I mean, that if you have that thing, because like, as you can see, I got into a bit of a problem actually running it in the REPL, because REPL itself, the command line of the REPL doesn't make a good editor. But what you can have a flow where in your editor, you're able to just use a shortcut to send that piece of code to the REPL to be evaluated. Yeah. So there's no compiling. Thank you, Badar. There's no compiling. It's sending that form, because it's all internal. Actually send the smallest or the biggest form to the REPL and get the result back.
Good. Thank you.
But yes, you need to have still a good flow with your editor if you're using a REPL. Okay. If there are no more questions, we are out of time as well. Well, thank you very much. Thanks for walking along with me. The question, what editor are you using and how do you connect with the REPL? I am actually using Vim. And there is a plugin called Fireplace. So Vim Fireplace. and you can go to GitHub, just search for Vim Fireplace, and it will show you. In fact, previously, in the previous examples, let me just go back up in so in this here, there is this called practically. I'm gonna put this in your chat as well, and it shows you how to set up your Clojure editors. Yeah, so you can, this is Vim Fireplace, but there are many other ways of doing it as well, because Vim is not for everybody. Cool.
Oh, thanks everybody. Thanks, Mash. We've had a lot of participation today, and there's no homework for the last session, I think.
The homework is make sure that you have the test environments running. So you're able to run tests from your editor. That's your homework.
Okay, so we do have a homework, everybody.
Yes, yes. Thank you for the reminder.
Okay, so last session is on March 23. I've sent the link if you want to register or have a look on the other events also that we have on Meetup. Thanks again, Mash. Thanks, Helder and Mateus.